And then 7.5.2 over here says 25 centimeters cubed of the oxalic acid solution, okay, is titrated against sodium hydroxide. The average volume of NaOH required for neutralization is 28.60 centimeters cubed. So we have our H2C2O4. This is a follow-on question. So we had the concentration of this guy, and they only used this much volume of it. So they took a little bit of this guy out in some sort of beaker. Let's draw a different beaker over here. We have something like this. Cool flask, nice, which means we have the concentration of 0.1 mole .dm to the -3, but they didn't just pour this whole amount into this other mixture. They just took a little bit, scooped it up, put it in here. We now have this much with a volume of 25 centimeters cubed, or we can convert that to decimeters cubed. So we have 25 centimeters cubed, or 0.025 decimeters cubed, and that's our volume. The visualization helps me, and very important to know what values we're working with in each beaker. But then, as I mentioned, the oxalic acid solution is titrated against sodium hydroxide. So sodium hydroxide here is from a different beaker. The average volume of NaOH required for neutralization is 28.60 centimeters cubed. So we have the volume of our NaOH over there, 28.60 centimeters cubed, or in decimeters cubed it is 0.0286, and that is our decimeters cubed. And the fact that they titrated it means this is the point in time where they reach equilibrium. That is just the term. So right now, for a 4-mark question, a very nice formula to work with, especially considering they mentioned the words titration and neutralization, is this formula up here. Our Ca times Va over Cb times Vb equals Na over Nb. The one where we can do ratios, so we didn't necessarily have to convert our centimeters cubed to decimeters cubed, but either way is fine. So I'm going to go ahead and write that, and we can plug everything in so we can see how that works. So we have our concentration of our acid times the volume of that acid over the concentration of the base times the volume of that base equals the moles of the acid over the moles of the base.